Last time, we showed you how medieval engineers built the unconquerable castle, every stone a weapon, every doorway a trap. But history has a brutal sense of humor, because for every unconquerable fortress ever built, someone eventually conquered it. Not by being stronger, not by being braver, but by being smarter. Siege warfare wasn't about power, it was about problem-solving under pressure. And the greatest siege commanders in history were problem solvers studying a system, searching for where it breaks. Today on Iron Registry, we're decoding the cold, calculated science of bringing a castle to its knees.
Before a single stone could be thrown, the attacker had to confront the full, terrible logic of what stood before him. The castle owned the high ground. His soldiers would climb into arrows. The walls were 20 feet thick. His rams would bounce off them like toys. The moat sat wide and cold. His sappers couldn't touch the foundations. The towers had no blind spots. There was nowhere to hide and nowhere to advance unseen. From the outside, the medieval castle wasn't just a building. It was an argument, a cold stone argument that said, the price of entry is more than you are willing to pay. But here is what the castle's builders never fully solved. For every defensive feature ever engineered, an attacker somewhere looked at it and asked one question: what is this designed to stop, and how do I stop that instead? The entire history of siege warfare is the history of that question being answered, feature by feature, wall by wall. If the castle is the lock, we are about to build the key.
The curtain wall was built to be an artificial cliff, impenetrable. The trebuchet was built to disagree. This wasn't a simple catapult. It was a precision instrument of mass destruction, capable of hurling a 200-pound projectile over 300 meters with devastating accuracy. But accuracy was only half its genius. The real weapon was repetition. A single trebuchet couldn't crack a 20-foot wall in one blow, but the same spot struck again and again. That's not a battle. That's structural fatigue. The wall wasn't being broken. It was being worn down. Height was the castle's greatest natural weapon. The trebuchet couldn't take that away, so attackers brought their own height. The siege tower is a multi-story engineering miracle. It's a literal skyscraper on wheels designed to neutralize 1,000 years of architectural advantage in a single audacious move. It delivers a strike team directly onto the ramparts, bypassing the killing ground entirely. It's a solution so direct it's almost insulting. You have the high ground, we'll just build a higher one.
While the trebuchets roared above, a silent, invisible war was being fought beneath the mud. This is sapping. The moat was a castle's life insurance against the undermining. It was designed to drown the sapper's dream. But where there was no water, the ground itself became the executioner. Miners didn't dig randomly. They targeted the Achilles heel, the corner of a tower where two massive weight vectors meet. They'd hollow out the earth, propping up tons of stone with a timber. Then they'd walk away and light a match. The wood burns, the support vanishes, gravity does the rest. 1215, Rochester Castle. King John is stuck behind the thickest walls in England. His miners are under the South Tower, but they have a problem. The wooden props aren't burning hot enough to trigger a total collapse. John's solution? He sends a royal order for the fattest figs least fit for eating. 40 pigs rendered down into high-grade fuel and packed into the mine. It wasn't just a fire anymore. It was a medieval thermal bomb. The South Tower didn't just crack, it disintegrated in minutes. A masterpiece of engineering, undone by a king's larder. The moat wasn't there to stop them, and the castle paid the ultimate price.
In the defense, the calendar is a shield. In the offense, it's a noose. A blockade is the ultimate engineering hack. It requires no trebuchets, no pig fat, and no ladders. It requires only one thing: relentless, ruthless patience. You cut every supply line and simply wait. The cellars and salted reserves by months. Eventually the larder runs dry, and hunger is a soldier that never sleeps. While they waited, the most ruthless commanders didn't simply starve the garrison, they broke them. Psychological warfare was as sophisticated as the engineering. Prisoners were executed in full view of the walls. Severed heads were launched over the ramparts. But in 1346, at the Siege of Caffa, the Mongols engineered a horror beyond the reach of stone. They began launching the bodies of plague victims over the walls. It is widely considered one of the earliest acts of biological warfare in recorded history. The castle's walls, so perfectly engineered against siege weapons,
had no defense against a fever you can't see. Then there was the clinical strike. Cut the water supply upstream, poison the well. The castle's greatest internal lifeline, that deep well sunk into the inner courtyard, was always its most fragile dependency. Contaminated, and the fortress fell not to any army, but to thirst.
Here is the one variable the master masons could never engineer around: the human heart. Most castles in history didn't fall to trebuchets. They didn't fall to siege towers, sapper tunnels, or plague. They fell to a single human hand, turning a lock from the inside. A postern gate, a paid guard, a starving soldier, a man who decided the attacker's gold was worth more than a dead king's cause. In the heat of a siege, the most lethal conversation wasn't happening on the battlefield. It was happening in the dark, in whispers. Take Château Gaillard, Richard the Lionheart's masterpiece: concentric walls, round towers. In 1204, it fell because of a toilet. French soldiers found an unguarded latrine shaft, crawled through the filth, and opened the gates from the inside. All that brilliance, all those millions of pounds of stone, rendered useless because no one was watching the toilet. Across history, the pattern repeats without exception. The longer a siege runs, the higher the chance that survival outweighs loyalty. It's a mathematical certainty. The castle's greatest defensive flaw was never architectural, it was human.
The castle was never a finished product. It was a living argument, constantly being revised by the trauma of war. Every time a siege commander found a cheat code, the engineers released a patch. Mining brought the deep, water-filled moat. This wasn't for aesthetics, it was a hydraulic firewall. You can't set fire to a tunnel support that's 10 feet underwater. The trebuchet brought angled walls and rounded towers. Builders realized that flat walls absorb the impact's kinetic energy. Rounded towers, however, defected. The stone glances off, the vibration is dispersed, and the repetition, the attacker's greatest weapon, is neutralized. By the late medieval period, the castle had absorbed 5 centuries of offensive lessons and hardened against all of them. Walls thicker, towers rounder, moats wider. Postern gates reinforced, surveilled. The final form of the medieval castle wasn't built by architects. It was built by every siege commander who had ever found a weakness and exploited it. It was a conversation between attack and defense that neither side could ever truly finish.
And here is the final truth that history teaches. Neither side ever definitively won. Every unconquerable castle eventually fell to time, to hunger, or to a technology it hadn't anticipated. And every perfect siege technique was eventually countered or rendered obsolete. The castle didn't fall because attackers got stronger. It fell because the world changed around it. Gunpowder arrived, and overnight, 5 centuries of stone logic became irrelevant. The argument was over, not because one side won, but because both sides were made obsolete by a third. The medieval siege wasn't a failure of defense. It was proof that no system, however perfectly engineered, survives contact with a sufficiently motivated, patient, and creative adversary. Build the wall high enough, and someone will always ask, "How do I climb it?" This is the Iron Registry, documenting the engineering of history. If you're ready to see how the other side held the line, watch our breakdown on castle defense